Hello everyone, my name is Meena, Assistant Professor in St. Martin's Engineering College, Department of Electrical and Electronics Engineering. Today my topic is classification of DC machine. So here in DC machine, we are giving to the DC supply to a machine is called as a DC machine. So here machines are classified into two types, that is one is motor and second one is generator. In motors, the input we are giving input is electrical energy is converted to mechanical energy. Electrical energy is converted to mechanical energy, it is a motor. And in generator, mechanical energy is converted to electrical energy. So this is the types of DC machine, and here depends upon the winding. We have the two winding, field winding and armature winding. Construction of field winding and armature winding, the motors are again classified into two types. One is separately excited motors, and second one is self excited motors. So in separately excited motors, the field winding is excited from the another DC supply. We are using the extra DC supply to excite the field winding is called as a separately excited machine. In self-excitation, we don't need another extra DC source. That is the purpose. This winding is called as a self-excited machine. Now coming to the PPT. So here we are using the separately excited machine. So the circuit diagram of a separately excited machine. So this is the separately excited machine. The winding is separately connected, and this is the armature. Here in armature, we have the EMF. That EMF is called as a EB. Back EMF. EB is called as a back EMF. RA is armature resistance and IA is the armature current. Here we are connecting one load, and next one is here we are requiring the another DC supply. When we are giving to this DC supply to this field, then this field winding will be excited. This field winding will be excited. So that is the purpose. It is this type of motors are called as a separately excited motor. And here from the motor principle, input is we are giving the electrical energy. So that is the purpose. The armature carries the IA current is flowing towards the load. This is the output. So here the load current is IL and the armature current is IA. And the VF is called as a field EMF. So here the voltage, here VF is field voltage and IF is field current. Then according to Ohm's law, V is equals to IR, same like VF is equals to IF into RF. And next one is here the EMF will be induced. This is nothing but a EB. EB is equals to V plus V is nothing but the load, the voltage across the load plus IA, RA. IA is armature current and RA is armature resistance. So this is the formulas for the separately excited motors. And these type of motors are mainly used in the industrial purpose, and it is also. So here the starting torque of these motors are very high. That is the purpose. This is mainly used in the traction. So when the in traction we require the high starting torque, and this is applications in traction, paper machines, steel rolling machine, and medical imaging devices and mining equipment. So this type of motors are, these are the application for the separately excited machine. And next topic is self excited machine. In self excited machine we have the three types: series motor, shunt motor, and compound motor. First one is shunt motor. Why it is called shunt motor means the field winding is connected in parallel to the armature. So clearly from the circuit diagram, so this is the armature. I am taking, this is armature, and across this terminal we have the connected RSH. So parallelly connected the field winding. So this arrangement, this total arrangement is called as a shunt motor. So this resistance is RSH, shunt field resistance. RA is the armature resistance, and here the voltage. According to KCL, the sum of the entering currents is equals to sum of the leaving current. See here, this is the point, this is the point. Take the point. According to KCL, the entering currents towards the node is equals to the leaving currents. Node is nothing but here I am taking the one is a node. So entering is IL current is entering, and the leaving currents will be ISH and IA. So from that equation, IL is equals to IA plus ISH. IL is the line current and IA is the armature current, ISH is the field current. So IL is equals to, this is the equation of a IL by applying the KCL. So from this equation I want the IA is equals to IL minus ISH. And next one is I want the field current, that is shunt field current. ISH is equals to V by RSH. According to Ohm's law, V is equals to IR, I is equals to V by R. So I am taking here the shunt field. So directly here the specification is SH, and here also SS. ISH is equals to V by RSH. So this is from the Ohm's law. And next one is I want the back EMF produced in the machine, that is EB. So for this circuit I am applying the KVL. According to KVL, the algebraic sum of the voltages around a closed loop is equals to 0. So EB is equals to, so how here I am applying the KVL, then V is equals to E plus IA RA. This is the armature drop is there, and this is the voltage, and this is also voltage. So here the produced EMF in the motor is called as a back EMF. Then what is back EMF? Back EMF is nothing but it is a voltage which opposes the supplied voltage. The EB is always opposes the supplied voltage is called as a back EMF. In motors, we are generated EMF is EB. This is always opposes the your supplied voltage. This is about the shunt field motor. And also the important point of shunt motor is this, the flux producing of this motors is constant. So it is called as a constant flux motor. So here the shunt motor is called as a constant flux motor. Why? Because here the flux is directly proportional to ISH. The flux is directly proportional to ISH. So the flux producing in a motor is directly proportional to the shunt field current. And also the resistance present in a field winding is always greater than the armature current. Because in armature resistance is very low, it is very low compared to your RSH. then the flux is called as this type of motors is called as a constant flux motor, because the flux is here developed in a motor is constant. That is the purpose it is called as a constant flux motor. And next one is, it is also called as a constant speed motor, because n is the speed of a motor is directly proportional to Eb by 5. Whenever the flux is constant, then the speed of a motor in a DC shunt motor also constant. So that is the purpose. The conclusion of this shunt motor is it is a constant flux motor, and the second one is it is a constant speed motor. And next one is, so here where we are applicable. So here the applications of DC shunt motors we are regularly using for the domestic purpose. That is mainly lathe machines, drilling machines, grinders, blowers and compressor. Why? Because it is a constant speed motors and constant flux motor. So we are rarely used motor is a DC shunt motor. In fan, lift, all the blowers, all the types of motors are coming into a DC shunt motor. And next one is DC series motor. So this is also one type of a self-excited machine or motor. So here the main difference of shunt motor and series motor, in series motors the field winding is connected in series with the armature. So here the current flowing through this field winding and the armature is same, because in series connection the current is same. So the total current is same out of the circuit, total circuit. Then I is equals to ISC is equals to IA. I is the total current, or otherwise we can take the IL. IL is equals to ISC is equals to IA. So IL is the line current from the voltage and ISC is a series current. And this series current is series and it is equals to the armature current. According to same for the KCL, here also I am applying sum of the entering currents is equals to sum of the leaving current. Here the total current is entering only, no leaving currents towards the armature. So IL is equals to IA is equals to ISC, because no division is not there. When the division is not there, the current flowing in a circuit is same. So IL is equals to ISC is equals to IA. And next one is voltage. Here we are applying the for calculation of voltage, applying the KVL for this circuit. Then according to KVL, sum of the entering some algebraic sum of the voltages around a closed circuit is equals to 0. V is equals to E plus IA RA plus ISC RSC. So here from this equation, how we'll get this equation means V is equals to EB plus IA RA plus ISC RSC. So from this equation, this is equation 1. From the equation, the IA current and ISC current is same. So that is the purpose. E is equals to EB plus I into RA plus I into RSC. In this equation, what is the common term? I is the common term. Take the common. V is equals to EB plus I into RA plus RSC. So this is the equation of voltage in the DC series motor. And next one is, in DC series motors are the high starting torque. This is very high starting torque because the RS value is means the series resistance is smaller than the in armature current. In case of shunt motor, RSH is higher than the RA, but compared to the coming to the DC series motor, RS value is smaller than the armature current. When the resistance will be low, high amount of currents will be flowing. How? According to Ohm's law, V is equals to IR. According to Ohm's law, V is equals to I into R, and then here from this equation I is inversely proportional to R. Inversely proportional means when the current is increasing, automatically the resistance value is decreasing. When the current is decreasing and the resistance value is increasing. Here we observed RS value is smaller. When the smaller value of resistance, the high amount of current will be flowing. In series motor, high amount of current will be flowing. So, and that is the purpose, it is not a constant motor. This type of motors are not constant motor. And next one is the torque produced in this type of motors is very high. The starting torque of series motors is high compared to shunt motor. So that is the purpose this type of motors are mainly useful for the traction. In traction application, we are using this type of motors, that is DC series motor. So, and next one is, another one is DC compound motors. This DC compound motor is nothing but it is a combination of series motor and shunt motor. In series motor, series and shunt, it is again classified into long shunt motor and short shunt motor. This is the combination of series and shunt motor. So we'll discuss about the first one. This is the long shunt motor. In long shunt motors, so first one is long shunt motor. This is the picture of a circuit of a long shunt motor. In long shunt motors, the diagram is connected in series winding is there and parallel winding is there. For example, I am taking this is motor. Here I am connecting the field winding. For this winding, I am connecting the series winding, and here I am applying the load. This is for the long shunt motors. In long shunt motors, the series is connected, the winding is connected. This is series winding, series field winding is connected to armature, and the shunt field winding is connected parallel to the armature winding. This is the combination of series plus shunt motors is called as a compound motors. In compound motor, so the EMF generated in this motor is EB, and here IA current is flowing. From here the IL current is flowing, and here ISH current is flowing. IL current, and this current is IL current towards the armature. So this is divided, IL is divided into two currents, that is IA plus IHS, same like your shunt motor. So in series motor, these are used mainly applicable for high starting torque, same like your shunt motor. This is the high starting torque, and the voltage, the equation in this same like your series equation, series motor voltage equation same, E is equals to, or V is equals to EB plus IA RA plus ISC RSC. Here in this diagram the field current is same in series, then total here the current is same and here the passing current is same, and here the different current is flowing, that is ISH. So these are mainly applicable for high starting turn. And next one is short shunt. In short shunt, so directly here this point, at this point only we are connecting one shunt field winding. So what is the difference between these two means? In long shunt motors we are directly connected armature resistance to armature series field winding, and this winding also direct connection is there. In case of shunt field motor, in short shunt motors, so this is the connection, this is EB. Here I am connecting the field winding, and next here I am connecting the series winding. So this is about the short shunt motor. So now we'll discuss about the equations in the short shunt motor. So what is the short shunt motor? That current is, so here the point, the current is entering and current is leaving. At this point current is dividing, the total current in this circuit is IA plus ISH. And next one is voltage is EB plus IARA. Here the IARA plus ISC RSC. These are the types of a compound motor. So what is the next one is application. So where we are using here the applications of a compound motor, sir, here the torque developed in a machine is very high. So that is the application we are using DC compound motor. And next one is generator. In generator also same, but what is the main difference between the motor and generator? For the generator, mechanical energy is converted to electrical energy. So here also same, separately excited generator and self-excited generator. In self-excited generator, we have the again classified into shunt generator, series generator and compound generator. Same, the working principle is same, but the equation is different. So this is the total overview of a generator. This is the classification, self and separately excited. In separately excited, these are the points. Okay, and next one is, this is the generator, separately excited generator circuit diagram. Here the direction of current is different compared to motor. So the generator, the current is flowing towards the load side. So IA current, IL current is equals then goes to load. Then the equation of voltage is equals to EG minus IA RA. EG is called as a generator EMF. And next one is, these are the shunt motors. Coming to the separate self-excited generator. In self-excited generation, same circuit, it is differs to the direction of current. So these are the currents. IA towards the IA is going to load. So IA is divided into two, ISH and IL. IA is equals to IL plus IHS. In motor this is different, IA is equals to IL minus ISH, and the EG is equals to V plus IA RA. In motor V is equals to EG plus IA RA, and the shunt load current or line current, IL is equals to V by RL according to Ohm's law. And next one is shunt field current, ISH is equals to V by RSH. And next one is series generator. In series generator, same, the field winding is connected in series with the armature. The IA current is flowing throughout the circuit is same. Then I is equals to IL, ISC is equals to IA, armature current. And what about the voltage equation? V is equals to EG minus IA into RA plus ISC. And next one is compound generator. Again here also long shunt and short shunt compound motors are there. This is the circuit diagram for the long shunt compound motor. So the winding is connected here, more number of winding is connected, shunt motor. Then ISC is equals to same like equation according to KCL and KVL, we can get the this type of equation. And next one is short shunt compound motor. In short shunt compound motor, directly we are connected here, the winding is connected here, then the current flowing, this current is equals to, this ISC current is equals to IL current, line current. Then ISH is equals to V by RSH, V plus IL RSC. V is nothing but EG minus IA RSC. Then IA is equals to IL plus ISH. So this is the types of your DC compound motor. So up to these topics we covered about the DC motors and DC generator. Now the important topic is, next topic is depends upon the this machine, the characteristics. The characteristics means we can give the performance by using this characteristic, we can find out the performance of each machine. Means self-excited machines are separately excited machine. In self-excited machines, shunt, series and compound is there, and separately excited machine. So we having the this one. And next, these are the graph. So torque versus armature current in DC series motor, because in DC series motors torque is directly proportional to Ia square times it is increasing, so randomly it is increasing at particular saturation. And the current in this type of motors are N is directly proportional to EB by 5. So when the current will be increasing, this is I is directly proportional to Ia, so directly it will be a decreasing. And similarly the speed of a motor and the torque also the same value, the same characteristics are there for the series motors. And next one is shunt motor. In shunt motor characteristics, shunt motors, so here it is called as a constant speed motor. So first we are taking the ideal condition, so randomly small changing in a speed, same like here also speed torque is same, here the random change is there. This is because of a armature IA graph. And next one is torque versus armature current, it is gradually increasing because the torque developing in a DC shunt motor, torque is directly proportional to Ia. So torque is directly proportional to flux. So this is randomly increases from linearly. So now we'll discuss about the video. I will show the video about this topic very clearly. So this is the video about the total picture of a classification of a machines. So types of DC machine, this is self-excited, this is the winding, this is the motor. And next this is a shunt field winding, and this is the series, and next one is compound winding. These are the three types of a self-excited DC machines are there. And next, these are the shunt field. For shunt field, we are connecting the parallel to the motor, and VT is the voltage, terminal voltage, VA is the armature voltage, and field voltage is VFA. This is the arrangement. We are connecting these two windings are connected in parallel. So this arrangement is called as a shunt field. And next one is, this type of motors are mainly used for the constant speed or constant flux motors. And next one is DC shunt motor. The flux is directly proportional to number of turns and the current. And next one is series motor. We discuss about the speed and torque. It is rapidly decreasing because the current, the speed of a motor is inversely proportional to torque developing in the motor. And this is about the compound motors. So in compound motor, it is a combination of series motor and shunt motor. So this is about the types of a different types of a DC machine. So this is the type of different machines and applications of a DC machines. This is a compound motor. In compound motor, combination of series and shunt field winding. This is series winding and shunt field winding. This is the highest torque. So these are the topics we are covered. For the main applications is for the constant motors, and these motors are widely used in industrial and domestical purpose. So that is the purpose. These are the types of a DC machines, means motors and generator is covered. And thank you.